The exam is coming up. Now you have to be careful. Exam 1 and 2, you have a few days time to get it done, and then you just kind of pick your time and you sit down and you get it done within that uh, few day window. The final exam isn't like that. The final exam does have a very set particular time that you have to take it on. So just a reminder, exam 1 and 2 has a little open window. The final exam doesn't. Okay. This exam coming up has 25 questions. You have an hour and a half, 90 minutes. It will be open up on Monday of next week, on week 8, and it will be open up through Wednesday of week 8. You only have one attempt to do it. It is closed book and closed notes. You can have that white board. They'll want to see that there's nothing written on it, and they'll scan your room. Remember to open up in the new tab when it provides it, to open up that formula sheet, and then also open up the Desmos calculator. You'll have those in the tabs before you actually start the problems themselves. So I always, suggest open those up and play around with using the Desmos calculator. And I will show you that, and I'll show you some tips and tricks as we go through. Yes, I I believe so. I believe it's the same. It should have the similar functionality, I would assume. Yeah. Okay, you're welcome. Okay. So we have some questions here that are either related to this week's assignments, or you might see on the actual quiz um, when you take that, or on the exam one. So if you look at question 1 here, it says a car rents for $175 a week plus 65 cents per mile. What is the cost for a family of 4 on a 2-week trip of 1,000 miles? Well, if you figure your 2-week trip, they're going to charge you that $175 twice for each individual week. So just multiply that 175 times 2. But then we also have to account for the total mileage. So if you do the total mileage times the mileage rate, 1,000 times 0.65 was the cost per mile. That would be $650. And then you add the two together, the total cost to rent the car for 2 weeks would be $1,000. So that's just kind of, sometimes you can even, kind of list out, well, what would they charge for the actual rental? What would they charge for the mileage? And then just add those two together. Okay. Your second question here is one of my least favorite on our homeworks and our tests. I just dislike this question so much, but I'll tell you the easiest way to get through it. Okay, it says 10 people bought textbooks. The electronic rental was $49.95. The new hardcover book, it was $169.95. 5 people bought the used book for $89.95. What is the best estimate for the cost of all 10 books? What I think to myself is, think about the word estimate. Okay, if you think about the word estimate, that's going to serve you well, because I would immediately think it's $50 for the, because that's just the easiest way to go. Make this 170 and make this 90. Okay. Now we know that 5 people bought the $90 one, so they've already spent $450 on those books. And then the best estimate, I think, would be to be somewhere in between exactly 170 and 50. So 170 plus 50, if we average that, that's 220 divided by 2, or the average is $110. So all we can do as a best guess, a best estimate, is think, well, the other 5 people average somewhere, if I could write it right, around the 110 mark. Then they spent somewhere around 550. Okay, and then I just add it up, and then that's $1,000. Okay, now the reason I dislike this is I'm a math teacher. And I never seem to get the exact number that they say. But I've always got it right if I choose the answer that's closest to the answer with my logic. Okay. So the answer that is closest, 890 is 110 too little. 1,100 is 100 too much. That's the closest value. So that to me is the best estimate for the price of the 10 books. Again, not a great question the way that it's formulated, but I've done that same thing every time I've seen it, and it serves me well, and it seems to work pretty good. Yeah, there you go. Exactly. Yep. So I think just kind of using a little bit of logic as to what kind of that middle value is for those other ones should work pretty well. Okay. Question 3. The circle graph here shows the most important problems for the 18 million or so high school teenagers in a country. Without using a calculator, estimate the number of high school teenagers for whom drugs is the most important problem. So if I'm not using a calculator, I am going to make that it's closest to 18 million. So I'm going to round that up a little bit. And then I'm going to find the percentage that has to do with drugs. And they say 23%. Okay. So 23% is 0.23. Okay. 23% is 0.23. We can multiply by 0.23 even without a calculator, if we want. It is asking for an estimate. And so making that 20% makes our multiplication a little easier, makes it 0.20. So let's multiply that by 0.20 and then see what happens. Well, we have to count that there are 6 zeros. And then there's a 0 there. So that's our 7th zero. And then if we multiply 18 times 2, that's 36. And then there are 2 things after the decimal. So we've got to have 2 things after the decimal. So the answer that is closest to what that 20% of 18 million, good estimates, is A, 3,600,000. So that's, uh-huh. So if you want to calculate 20% of the total, and that does mean multiply. 20% is the decimal point 20. And so you would multiply that 18 million approximate, because they said the word estimate again, times the 20. And that's where I got the 3,600,000. Now there is another technique for percentages. Yeah, I call it is over of equals percent over 100. The is sometimes even referred to as the part you're looking for. The of is the total you have, and the percent is the percent. So if you apply that is over of equals percent over 100 to this application, and I'm going to kind of put it here in the center, it would be what part out of 18 million would equal 20 out of 100. And if you solve that, you would cross multiply, and then you would end up having to divide by 100. You would still get that 3,600,000. Yeah, there's lots of ways to do every math problem, so I try to, kind of give you lots of choices. In question 4, they want to know where the tens place is. Remember, the tens place is after the decimal, one place. And the way I think about it, the number 10 has 1 0. I need to be one place after the decimal. So if we want to identify the tens place, that is the 8 right here. And if we want to round to the nearest tenth, let me write this number a little bigger. So we're focusing in on that 8, and we're looking at the number directly behind it on the right-hand side. If that number is 5 or more, the 8's going to go up to a 9. But like this case, if that number is less than 5, we keep the 8 as it is. So the answer would be 2,167.08 would be our, no, it is not. Oh my gosh. I'm sorry. I said one decimal place, but I sure didn't point to one decimal place. How about pointing to one decimal place is that? I'm so sorry. Let's rethink that. So one decimal place, Mrs. Hott, is right here. It is in that spot, and we are looking again if something right behind it is 5 or more, we're going to round it up so the 0 will become a 1. If that number in the place right after it is less than 5, keep it the way it is. You would even write the 0. One of the things I noticed in Canvas is you would want to type in 2,167.0 if they needed the tens, if it didn't round up. Some people don't want to write that 0, but please make sure that you follow whatever instructions is given. So if it says to the nearest tenth, show one place. If it says to the nearest hundredth, so show 2 places, or whatever the case may be. Now, we're going to take that same number and we're going to go to the nearest thousandth, which is 3 places after the decimal. Now, 3 places after the decimal is the thousandth, so that's the 4 right here. So if you identify the digit in the thousandth place, that is the 4. And to round it to the nearest thousandth, we have to look at what directly follows it. And so in this case, is 6. Since that's bigger than 4, 5, 6, 7, 8, or 9, we're going to round that up to a 5. And make sure that you type in to, like Canvas when you're doing these, if it says thousandth, make sure you show 3 decimal places. Now this one says to the nearest hundredths. Now one thing you might notice that's different is they have not shown that TH. So hundreds, I think of 100, what is the number 100 looking like? So in the hundredths place, this is ones, tens, just like the number 100, it is that 3rd place right there. So if you look at even write the number 100 and use it as a guide, where would it stop? Where would it be located? That's the nearest hundredth. Now let me write it a little bigger. So that's the nearest 100 right there. And after it happens to be a number that is 5 or larger. So we're going to round that up. And because it doesn't have the TH, there is no decimal value we have to deal with. So you can just end it. I wouldn't even suggesting putting the decimal point at all when you're typing it in Canvas. When you don't show the decimal place at all, that's implying that it's a whole number, which this is, rounded to the nearest 100. So just, so you know how that would be written. I don't even think put in that decimal place. I think it might confuse it. Now, when I go through and grade everything in Canvas, if somebody accidentally types that decimal point, they still have the right answer. So I give it to them, but initially Canvas marks it wrong. So one thing to note is, I go through before I release the grades to you. Sometimes you'll get a grade initially when you take a quiz, but I'll release the grades to you. And when I do, your score might change because I've gone in and said, well, that one's actually correct, and I'll adjust that accordingly. Yeah, and also if you go and look at old quizzes and homework assignments, I put comments in there if you miss a problem that it kind of will say, okay, you missed this because of here's how you do it. So I do try to give you feedback so that when the test comes along, you can see what you've missed. So I usually release all of that by Tuesdays. So it's due on Sunday, and usually Tuesdays I'll release all those, and I will put comments that you can take a look and see some hints about what you did wrong. Yeah, it could be helpful, especially when leading up to a test. But when it's in the moment, when it's in your mind, so you can then see, oh, well, I should have done it like this, and it'll might clarify something for you. Now, this one here says that we want to identify the digit in the ones place. The ones is just like the number one, it's one digit. It's to the left of your decimal place. So the 7 is what they're looking for, is in the ones place. If we want to round to the nearest whole number, that's rounding in that ones place. If the number behind it is less than 5, we're going to keep that as 2,167 in this case. We don't need to change that unless behind it is 5 or more. Okay, now here are some conversion questions. So there's some facts that you need to remember. Remember, you'll have that conversion tab open. The relationship between ounces and pounds is that 1 pound is 16 ounces. So you can find that on your conversion sheet. It's there. You might have to search around for it, but just look for all of the information about weight. Pounds and ounces are the standard system, so it is under that label. So we already know we have 42 pounds. So we just need to add, well, what are the ounces? How does that relate? Well, if you think about the fact that 1 pound is 16 ounces, then how many pounds would 8 ounces be? So relying upon a proportion for almost all conversion problems, or many of them, is a very helpful thing to do. So I tend to use a proportion. To solve a proportion, what's nice is you always do the same thing. You cross multiply. If you get a number stuck on your x, so 1 times 8 is 8. 16 times x is 16x. If you get a number stuck on your x, all you got to do to solve this proportion is divide by 16. Now, you can leave that 8 over 16. It is not a reduced fraction. 8 and 16 both divide by 8. So you can get 1/2, or you can actually even divide it and get 8 divided by 16 is 0.5. So it's 1/2 of a pound, that's 16, or that 8 ounces. Yes, that's what I was going to say. So it depends on how they ask the answer. If they say you can put the answer in fraction form, it would be 42.5. If it says they accept, decimal form's fine, 42.5 is also an acceptable way to write your answer. Yep. Now, here is the conversion between a standard measurement, pounds, and a kilogram measurement, which is the metric system. So it's kind of a mixed kilograms to metrics. Now, what I always kind of used for pounds and kilograms was that 2.2. That's a very common thing, but I noticed that our conversion sheet doesn't use that. Our conversion sheet says that 1 pound is 0.45 kilograms. So if you don't use that conversion from the conversion sheet, you could possibly get the wrong answer. So I always suggest using exactly what is on the conversion sheet so you get the correct answer, okay? So if we want to convert 195.3 pounds, we're going to use this fact to set up our conversion factor, our part of our fraction. So I know 1 pound is 0.45 kilograms. So the question is, since this is pounds on the top on the left, I got to put pounds on the top on the right. That's the way you just make sure it lines up. So that's 195.3 pounds. And the question is how many kilograms it is. So just make that your X. And that just allows that you set up your proportion right. If you put pounds over kilograms on the left, you got to put pounds over kilograms on the right. You have to do the same thing. Okay. Again, cross multiply. Well, 1 times X is just 1X. You don't need anything. You can just write X. So we know that it's going to be 195.3 times 0.45. That's the multiplication we have to do to answer the question in one easy step. So the proportion, by setting it up correctly, it kind of tells you, am I multiplying by 0.45 or am I dividing? In this case, we'll multiply by 0.45 and we get 87.885. Now, usually on Canvas, it will give you information about how many decimal places to round. It might, give you some information about that. Our kilogram measurement is to 2 decimal places. Maybe they want 2 decimal places, just make sure you're following the instructions. So in this case, if we did 2 decimal places or to the nearest hundredth, this would be 87.89 kilograms. Sure. Yeah, me too. And if I don't know if it maybe it's more accurate if you take, because I asked the same darn thing, 1 divided by 2.2, you do get 0.45, 0.45, 45, 45, 45 repeating. So it is the same almost. And the problem is I found that the people that were using 2.2, it didn't always convert quite to the correct answer. So just use the conversion. And again, that's what my brain went to all the time. But the conversion sheet says 0.45. So that's what I would use to make sure that, and I don't know if they use that because it rounds that 2.2. I have no idea. I just work here. I don't know. Yeah, you would do 2.2. Guess what? So would I. I have no clue. I have no 0.45. Now, number 10, we are going to use the same conversion, but you'll end up seeing that our math will go slightly differently. So we know 1 pound is 0.45 kilograms. So this time we are given kilograms. Since I put that on the bottom on the left, I've got to put that on the bottom on the right. My unknown, my X value, would be the pounds, which would go on the top. Now, what that does is it sets me up for success because when I multiply here, that's just 65.8. When I multiply here, that's X times 0.45 or 0.45X. You can just throw it in front of the X. And that tells me that I still have to divide that off. So 0.45 divided into 65.8. And it will a little bit more than double it. So that 2.2 is kind of in there a little bit. But 65.8 divided by 0.45 will kind of double it in a way. You get 146.2 repeating. Again, watch your decimal places. How many decimal places do they want us to go to? 146.2, 146.22, who knows? I don't know. It did every instruction, just watch those instructions. I find that some students are, you'll do the math, I think you're doing it right. And then I notice that you'll enter things without really thinking through what the instructions are. So really read that instruction, do your math, do it just like I did, and then read that instruction line one more time. Well, how did they want me to round? You know, if they wanted the nearest tenth, it would be 146.2. If they wanted thousandth, it would be 146.222. So just be careful about whatever they want you to round, for sure. Okay, now question 11 goes from milliliters to teaspoons. The conversion, so if you look at volume, that any kind of liquids would be under the volume section. 1 teaspoon, oh, that's tablespoons, I'm sorry, let's change that. If I could read here. Convert 45 milliliters to tablespoons. 1 tablespoon is 15 milliliters. That is on your conversion sheet. So you just got to find what is that relationship so that we can set up a proportion. So 1 tablespoon, I'm just going to put a big T for tablespoon, is 15 milliliters. So how many tablespoons would be 45 milliliters? Now, if you use some logic, you might already know it's 3. 15 plus 15 plus 15 is 45. But mathematically, again, we can always use the cross multiplication trick. 1 times 45 is 45. X times 15, just write as 15x. And that tells me I have to divide by 15 to get the correct answer. 45 divided by 15 is 3. So our answer is 3 tablespoons. So you don't have to use proportions. I just find it so consistently helpful. It kind of will give you the, you know, am I multiplying or am I dividing very nicely? So I do tend to use it as a conversion trick. It's very helpful. Oh, that's good. Yeah, keep your now. Now here for the 18 tablespoons to milliliters, we know that every tablespoon is 15 milliliters. So every one of those tablespoons has 15 milliliters in it. So if that reminds you that you're going to multiply 18 times 15, go for it. You know, let me show you the proportion. So we know that 1 tablespoon is 15 milliliters. So 18 tablespoons is how many milliliters? And you can see right here, it tells us we're going to multiply 15 times 18, 1 times x. 1 times x is just x. 15 times 18 is 270, and that is our answer. 270 milliliters is equal to 18 tablespoons. Grams to kilograms. Now, anytime you're stuck within the metric system, the metric system uses a nice little chart. Now, it's written one way in the conversion sheet. I'm going to show you how I like to do the metric conversions in a kind of silly way. You can take the chart that's given, rewrite it the way I do, and then it actually makes the conversion happen so nice. Okay, you don't even have to use a proportion. Anyway, so if you take the conversion sheet and you write just the abbreviations, K, H, D, and then I'm going to just put unit right here, and I'm going to kind of write it sideways. Centi, milli, and then I need 2 little placeholders, and then MC for micro. Okay, so it's on the sheet. It's in a box. Just write it from left to right instead of up and down. So kilo, hecta, deca, units. There's a spot that says units, and then centi, milli, and then you need 2 little placeholders, and then micro. Okay, here's why it's so nice. If we are going from 182 grams, which is our unit spot, and we are changing to kilograms, this is so nice. Go put your pencil on the unit spot. So just put your pencil right there and count how many jumps it takes you to get to the K, because we've added a K onto the units. That's how we get kilogram. And if you count the number of jumps, that's 1, 2, 3 jumps to the left. So all you got to do is take this decimal, because the metric system is powers of 10 and our number system is powers of 10. All you got to do is take this decimal and do the same number of jumps in the same direction. So 1, 2, 3 to the left. The answer is 0.182, but in nursing, you always want to show your front zero. So that is the way to use my little chart. It's given to you. There's a little moniker that goes with it. Kittens hide down under dad's car motor. That also works for this if you had to memorize it. We don't have to memorize it. It's in our conversion chart. But it's just a way to, go back and forth. So I was at the unit spot. I have to jump 1, 2, 3 to the left to get to my kilo. Count jumps. 1, 2, 3 jumps to the left. And it does work really great. Now, what you can also learn is that 1 gram is 1,000 kilograms. That's also on the sheet. If you do a conversion, 182, I had this, I don't have that written right. Can I say that again? 1 kilogram is 1,000 units. 1,000 grams. Thank you. I'm like, oh, sorry about that. So 182 grams is how many kilograms. And if you do the math, you do have to multiply 1,000 times x, 182 times 1. So 1,000x equals 182. So you do have to divide by 1,000, which moves the decimal place to the left 3 places. Now, my little silly way jumps the decimal place for you, and that's why I've always kind of used it. It's helpful. Just a way to think about it if you want to. So, yep, that's a great tool for sure. Okay, for these ones, it says to convert from Celsius to Fahrenheit. I believe that the conversion sheet has those formulas on it somewhere. But let me write down the formula for you, and I don't want to write it wrong, so. Yep. Okay. So to find the Fahrenheit, when you know the Celsius, you can take the Celsius degrees times 1.8 and then add 32. So that is the easiest way to convert from Celsius to Fahrenheit. So if you do that, your 24.6 is in Celsius. It's going to go right there. If we think about order of operations, multiplication has to happen first. So if we multiply 24.6 and 1.8, we get 44.28. And then you just got to add 32 to that. And so our Fahrenheit degrees would be 76.28 degrees. Now, since the original was 24.6 and it was only to 1 decimal place, watch if they mention how to round your answer. If we rounded that to 1 decimal place, it would be 76.3 degrees Fahrenheit. Okay, is that one good? Let me make sure I didn't do something weird. We good? We good? Okay. Okay. Now, we should also be able to go the opposite direction. So that one, the formula starts out C equals, and then we've got to calculate the formula. Now, I've seen it written a few different ways. Do you know how, if you look at this formula, we are multiplying by 1.8? So I've seen it where people have used the fraction. There's like a 5/9 and a 5/9 and 9/5. So I've seen that used. But you can also take the degrees and think about doing the opposite. We would have to subtract off 32. Well, let me write the formula first before I jump in and do it. You can take the Fahrenheit, you can minus off 32, and then divide by 1.8. So if you kind of redo the formula that we just saw, that's one way. I've also seen it where you write 5/9 times the Fahrenheit minus 32. So either way is correct. 9/5 flipped upside down, or 5/9 flipped upside down is 1.8. But anyway, it doesn't matter. Either of them will work for you. But the first thing you have to do in either formula is take that 100.2, take off 32. We're going to ignore that 1.8, and 100.2 minus 32. Make sure you get that answer of 68.2 before you divide by 1.8, just following order of operations. And we get 37.8 repeating. And now that's where rounding comes into play. Make sure that you round that to whatever decimal place they have given. If we rounded that to the tenths place like we saw earlier, the 8 is followed by another 8, so it would round up to a 9. So, just be careful with how you round. Follow those instructions, because it can throw you off if you're not completely following those instructions. Prime factorization. I'm going to show you my tricks and some things that I use to factor. What I always look for is I try to divide by 2 as many times as I can initially. So if we divide this by 2, and I'm just going to kind of go downward. You can use a factor tree. You can use my division little box. It doesn't really matter, really, whatever you like. 63,504 is divisible by 2 because the end digit 4 is an even number. So if we divide that by 2, we get 31,752. The last digit is still, bless you, is divisible by 2, so we can do it again. If we divide it by 2 again, we get 15,876. Still the last digit's divisible by 2, so we can divide it by 2 again. And we get 7,938, which is still divisible by 2 because the last digit is an 8. And we finally get to this point where we're no longer divisible by 2. So the next thing, there's a trick for 3s. If you add up all the digits and the sum is divisible by 3, the whole darn thing is divisible by 3. Well, look at every single one of those numbers. 3, 9, 6, they're all divisible by 3. So it makes sense that that number is divisible by 3. But you can check it on a calculator if you wanted to. If you divide it by 3, you get 1323. Now that one's a little bit harder to detect, but it is divisible by 3 as well. 1 plus 3 plus 2 plus 3 is 9. You add all those digits. If it's divisible by 3, so is the big number, which I think is so weird, but it does work. So if we divide that by 3, we get 441. We can do the trick again. 4 plus 4 plus 1 is 9. So since that number is divisible by 3, that big number is 2. So do it again. I'm going to run out of room here. We get 147. 1 plus 4 plus 7 is 12, which is divisible by 3. So I bet we can divide by 3 again. And we get 49, which is 7 times 7, and we're done. So let's rewrite that a little bit. I have 4 2's, so that's 2 to the 4th. I have 1, 2, 3, 4 3's, so that's 3 to the 4th. And I have 2 7's, so that is 7 squared. Okay, so that's the prime factorization of that number. Fun stuff. Now let's do the same thing to this one. Okay, let me scooch it over just a little bit. Okay, I noticed the last digit 8 is divisible by 2, so I'm going to do my 2 trick. 38,808 divisible or divided by 2 is a number that's still divisible by 2. So I'm going to do it again. That one's still divisible by 2, so I'm going to do it again. Now we're not by 2's anymore. 4 plus 8 is 12, plus 5 is 17, plus 1 is 18. That whole thing is going to be divisible by 3 then. So I'm going to try 3. Let's try that. 1 plus 6 plus 1 plus 7 is not divisible by 3. Oh, is it divisible by 7? Well, since 7's were in the other one, I did try 7. It can't divide by 5. Yeah, maybe it is divisible by 3. Yes, that's where I got the 4851. And then the 4851, I divided by 3, got 16, 17. And then, oh, it can divide by 3 again. And you get 539. And then 539 isn't divisible by 3, but 539, if it ends in 9, I always try 7, since that might sometimes ends in 3's. It is divisible by 7. And 77 is a nice one because you can recognize what's in there. That is 7 times 11. So that number is 2 to the 3rd, 3 to the 2nd, 7 to the 2nd, and 11. Okay. So all I'm doing is I'm just dividing, and I was using a calculator. If it's even, divided by 2, even, divided by 2, even, divided by 2. And then it's no longer even, so then I try 3. And I just divided by 3 until I no longer could. The trick about 3's is if the digits add up to a number that's divisible by 3, it will as well. 1 plus 6 is 8 plus, no, it isn't. 1 plus 6 is 7, plus 1 more is 8. 8 plus 7 is 15, which is divisible by 3. But you can just throw in a calculator, does it divide by 3? And it will. Yeah. Uh-huh. It doesn't end in something that's even. You can then I jump to 3's. Yeah. Yeah. Yep. Yep. Okay. So I'm going to write these down here because I need this for the next problem. So 63,504 is 2 to the 4th, 3 to the 4th, and 7 squared. And 38808 was 2 to the 3rd, 3 to the 2nd, 7 to the 2nd, and 11. Okay, I think I need that. Yeah. Let me copy that for the next one too. Yeah, it's just like trial and error to an extent. There are some rules that kind of help you narrow down. But if worse comes to worse, keep trying 2's, 3's, 5's, 7's. You know that's going to get you until you start recognizing what's in there. Okay. So this one says to find the greatest common factor. The greatest common factor, we're going to use any factors that they have in common to the lowest power. So the key is, even though it says the greatest common factor, we have to use the lowest thing they have in common. It's a common factor. They have 2's in common. The lowest factor is 2 to the 3rd. So we can only use 3 that they have in common. They have 3's in common. The lowest is 3 squared. They have 7's in common. They're a perfect match, so that's in common, so we need 2 of them. They don't have 11's in common, so we can't use that. And then you can just put this into a calculator. Technically, it's 8 times 9 times 49. Yeah. Correct. So compare the things they have in common. They have 2's in common. The lowest power is what you're going to pull out. So we need 3 2's. The 3's they have in common, the lowest power we're going to pull out, they have 2 of them. And the 7's they have in common, and they both have 2, so we get to use 2. And then you could just throw that into a calculator using the power button. Desmos has a power button as well. So if you throw into Desmos, it would be 2, use that AB button, and it was 2 to the third. Just make sure you come down to the normal level before you hit 3 squared. Come down with the little arrow, and then hit times 7 squared. So Desmos will do powers nicely for you. And then you just hit the little, for me, I'm on an iPad, so it's a little different right now, but enter or return. And you see the number is right there in the corner, 3,528. So that's what I got here, 3,528. Now, the way that you can check, you should be able to divide that evenly into both numbers. It is a common factor, so it can divide into the answers. And that's the way I like to check my work. Can I divide that into this and it comes out with a nice whole number? Can I divide it into that? Does it come out to be a nice whole number? So I do use that, but that is our answer. Now, going the opposite way, the least common multiple. The least common multiple, for that way, we need to use the highest power and all factors. Okay, so the least common multiple, because they have to divide into it, is going to be the biggest number or bigger. So it's a big number. The greatest common factor is usually smaller than what you got. Least common multiple is going to be possibly bigger than what you got. So we have to use 2's, but this time we use 4 of them. We have to use 3's, but we have to use the biggest. We have to use 4 of them. We have to use 7's. The biggest is 2 of them. And we have to use 11. The biggest is just an 11. And then again, you could put it into Desmos, or well, on the test, you could put it into Desmos. Well, it's the same thing even if you compare here. There's not 4 2's, but we have to use 4 of them so that this number will divide into our result. If we don't have 11 in our big least common multiple, this number won't divide into it evenly. So that's why you pull out the highest one of those, the highest one of those, the highest one of those, and even the non-common factor, the highest one of those will be whatever it is in the other number. Yeah, like, yes, so if there's a 5 here, we got to have a 5, whatever, for at least common multiple, it's got to include every single thing to the highest power that you ever see it, wherever you see it, even if it's not a common factor. And so our final answer for this one if I entered it right, is 600 and 98,544. So look how much bigger it is. But if you put into your calculator, does 63,504 divide into it? Yes, it does. 11 times. Does the other one divide into it? If you put in the 38,808, yes, it does. So you just have to, you can check your work by checking out, does it divide into it and all that good stuff. So that's that one. Here is just some quick order of operations and sign numbers and things. Remember, if the signs are different, we're going to subtract them. 8 and 9 subtract for a difference of 1. And you're going to keep the sign of the highest absolute value, so it's going to be a negative 1. You can also think about it like this. If I am, so this is, positives and this is negatives. I don't need to be accurate, but anyway, if I am at the positive 8 spot and I go backwards 9, so there's 0, I'm going to end up at negative 1. So, and you can also even sometimes thinking of real life stuff, especially like temperature. If it's 8 degrees out and it drops 9 degrees, now I'm at negative 1. That's sometimes helpful. So here, negative 12 plus 8, if the signs are different, we subtract, keep the sign of the bigger one. Now, be careful when you subtract in algebra, you're really adding the opposite. So when you see this two negatives sitting next to each other, I like to rewrite it first before I decide what I'm doing, because now I can see that they have different signs on them. I subtract, keep the sign of the bigger thing. So two negatives sitting next to each other make a positive. The opposite of a negative is a positive if you think of it like that. So here this would be 8 plus 3, which is 11. Yeah, the two negatives will make a positive 3, and then that 8 plus 3 would be 11. So I convert it first, and then I do any addition or subtraction. Good? Okie doke. Now here we're going to translate a problem. It says, subtract 7 from 9. So we have 9. We're going to subtract 7 from it. So I do that first. We're going to multiply this thing, so it needs parentheses, by 5. That difference, that thing, that subtraction gets multiplied by 5. And here's, I noticed on one of the, I don't know if it was in one of the homeworks or the quizzes when I was grading over, when it says to square the product, you either need brackets or just another set of parentheses. Around that whole thing, we need to square that whole multiplication. So that one is, I noticed some people were putting the square by the 5, but that would only square the 5. You must either put brackets or parentheses to tell it I'm going to square the whole thing. So that would be the answer they want for that. They didn't say whether or not, I know in the homework, they just had you set it up. They didn't do it. If we were to do this, we would get 2 times 5, which is 10. And when we squared that product, it would become 100. So if they did want you to actually do the math, that's what the math would be. Now, if we look at this order of operations, because we're kind of running out of time, I'm going to talk fast. So it says use order of operations to simplify the expression. Let's do the squares first, order of operations. I think as please excuse my dear. Yep, Aunt Sally. But I think of it in 4 steps. We have to do any parentheses or like grouping symbols, then exponents, multiply and divide from left to right, then add and subtract from left to right. Some people, you say the word multiplication first. It doesn't come first. It's from left to right. So sometimes division wins if it comes first. So that's why I think of it in 4 steps, if that helps you. Okay, so if we do the powers, we get 64 minus 16 divided by 4 times 7 minus 2. And then I have some multiplication and division. I have to go from left to right. So I'm going to do this, then I'm going to do this, okay? So 16 divided by 4 is 4. 4 times 7 is 28. Now I just add and subtract from left to right. 64 minus 28 is 36. Minus 2 is 34. So just be careful. It's really kind of a 4-step process. Any grouping symbols, we didn't have them on this one. Then exponents came next. Multiply and divide from left to right. That's why that division happened first, because it was to the left. And then add and subtract as you go from left to right. Same thing, another order of operation. So we have this grouping symbol. So we have to go in there and do the math to that. I see 2 negative symbols sitting next to each other. So I'm going to make that 6 plus 3 before I decide what to do. Well, 6 plus 3 is 9. Now, we're going to have to do some multiplication. If you want to think about this as the opposite of 9 or -1 times 9, that's a good idea. So you can consider that a multiplication if that helps your brain. And then 2 times 7 is our next multiplication. And then we only have addition and subtraction left. Go from left to right. -2 minus 9 is -11 plus 14. They're opposite signs, so we're going to subtract. Keep the sign of the bigger one. It is a positive answer. You don't have to input positives or put a positive, but yeah, it is a positive 3. This is about this timeline. Now, there were some things on the test, yeah, or one of the quizzes about this, and some people were getting it wrong, so I did want to talk about it. When they say the difference of 2 things, the difference of 5 and 9, you would put 5 minus 9. You have to put it in the order they gave it to you, okay? So they say the difference, that tells me I'm going to subtract 2 things. Between someone who eats red meat more than twice per week, so let's find that value. Someone that eats red meat more than twice a week is at the -5 spot, minus the difference of someone who eats 5 servings of fruits or vegetables. Fruits or vegetables is at +3. And so we get -8. Now, what does that mean? Well, if you get a positive value, that means that that person would live 8 years more. But the eat red meat is to the left of it. So the difference, it is 8 below it. So if you count it all the way to here, that would be 8 jumps. 1, 2, 3, 4, 5, 6, 7, 8. Now, if they said the difference between someone who eats 5 servings of vegetables and someone who eats servings of red meat, then those 2 numbers would switch location. So watch the order in which they say it. It will matter in your final answer. Those are weird ones. Decimal form of 5/9. You're just going to do 5 divided by 9. I believe that's something that the Desmos calculator will do. If you hit 5 divided by 9 in that corner, you can see it right there. See the 5s are repeating. Watch how they want you to round your answer. Now, if they say, if it's multiple choice, which sometimes it is, they should put that little line over top, which means that number repeats endlessly forever until the end of time. If they say rounded to the nearest, let's say they say rounded to the nearest 1,000th, then our 1,000th position is the 3rd position. That 5 would go up to a 6. So that's to the nearest 1,000th. This is the exact answer. They should include that little line over the last 5 they write, whichever number they write. Okay. Is 1/8 plus 1/10 2/18? Well, I'm going to tell you, I don't think so, but let me show you why. In order to add fractions, you must have a common denominator. But I'm going to show you how to do this on Desmos as well. Is 1/8 plus 1/10 the same as 2/18? So if you do 1/8, 1 divided by 8, plus 1 divided by 10, a decimal is going to show up in that bottom corner. See that bottom corner right there? Okay. If you do 2 divided by 18, they said, are they equal? See how the decimals don't match? Yeah, so if the decimals don't match, you can't say that they're equal. So you can check it on your Desmos calculator for sure, okay? But mathematically, let me show you how. To add those two fractions, we would need to get a common denominator, which is 40. So we'd multiply that one by 5 and that one by 4. So 5/40 plus 4/40 is 9/40. They're both divisible by 2. If you divide them by 2, no, they aren't divisible by 2. They're not divisible by anything. I saw the 2/18, and so it's the reduced form for 9/40 is not the same as 2/18. So that's a no. But we can see that the decimals didn't match in Desmos. Same thing here. Is 5/9 divided by 10 the same as 1/18? You throw each individual piece into Desmos. What is it telling you it's equal to? But 5/9 divided by 10, just put it over 1. Do the little weird, silly rule. Keep, change, flip. Keep, change that to a multiplication. Flip that over. Keep, change, flip. So keep, change, flip. And then we can multiply tops with tops, bottoms with bottoms. We can reduce first, reduce after. It doesn't matter. That's 5/90, which is the same as 1/18, which is exactly what they said it was. So that's a yes. But you can check those in Desmos. They do calculators. To get the calculator to do a fraction, 5/9 is 5 divided by 9. And so it should work out pretty nice. Yeah, you can only use the Desmos calculator, so practice using it. If you put Desmos in, there's two choices. I think one's a scientific calculator and one's a graphing calculator. You want the scientific calculator. So. What I believe happens is before you, after you do like your scan of the room and all that other junk, then from there, I believe that um, they're going to give you links to 2 tabs and they'll say, please open up these tabs before you begin the exam. So you'll click each of those tabs, go back to the tab you were in, and then start the exam. And you leave those tabs open and you'll be able to get back to them as you go through the process. Yeah. You're welcome. To divide these two, you cannot divide fractions unless they are in improper form, if they start out to be mixed numbers. You just do the little trick. 2 times 9 is 18. 18 plus 5 is 23. 4 times 1 is 4, plus 3 is 7, so that's 7/4. And then we're going to do the keep, change, flip. So keep, change, flip. Okay. And then we're going to multiply tops with tops and bottoms with bottoms. Now I see a 63 popping up, so there is a chance that we're going to be okay. 23 times 4 is 92. 7 times 6 is 63. Is it 1 and 29/63? Again, you can use Desmos. 92 divided by 63. Is it the same as 1 plus 29/63? Well, if you take 92 and you take off 63, that is 1 whole. It does leave you 29 left over. And so it's a yes. It is equal to 1 and 29/63. Yes, yeah. You can even do the old school. 92 is on top, it's your divisor, I mean your dividend. 63 goes into there one time with 29 left over. Yeah, yeah. Simplify the expression. The rule is if the bases are alike and you are dividing, keep that base, subtract the top exponent from the bottom. So this would be 7, and you subtract the top from the bottom, it would be 7 to the 5th. Now, if they wanted to in just power notation, 7 to the 5th is fine. And so that's fine. If they want you to actually do that multiplication out, Decimus would do that. That is 16,807. Scientific notation, we want the decimal place to get us where our number is some number between 1 and 10. It's allowed to equal 1, but not 10. So kind of think in a way the front digit is between 1 and 9. So we want it to be 1.297. We know it's 10 to some power, but let's figure out how many. If you take the original location of our decimal place, 1, 2, 3, 4, 5, 6, 7, 8, 9 places to get us there, 9 jumps. So if the number is more than 10, you use a positive exponent on the 10. If your number started at a 0 point something, you need a negative number to depict that. The positive means I'm multiplying by 10 again and again and again, and in this case 9 times. A negative means you're dividing by 10. That's why the negatives are only used for those small decimal values. Now, sometimes it depends upon how many significant digits are there or how the question is written. I could see this being rounded to 1.3 times 10 to the 9th. Yeah. So just to really kind of watch what the answer, I would leave it unless they say to round it somehow. Yeah. I would leave it unless they mention something otherwise, you know. Science classes, they use that the significant digits sometimes a little more often. So in a scientific application or scientific class, you might need to round to so many places. But unless they say otherwise, just convert it and leave it in a math class most of the time. So yeah. Okay, so we want our decimal place to go right there. So it's 9.735, a number between 1 and 10. To get there, we have to count 1, 2, 3, 4, 5 jumps. So our 10 to the 5th has to be a negative 5 to indicate that we technically were dividing by 10 by 10 by 10 by 10 5 times to move the decimal place back to its original 0.00009 location. Okay, so if a number is bigger than 10, your power is always going to be positive. If a number starts out 0 point anything, your power is always going to be negative. So now to go backwards, again, this really means 1.35 times 10 times 10 times 10 times 10 times 10. You're multiplying by 5 tens. That's going to make that number really big. So you can physically do 1.35 times 10 times 10 times 10 times 10, or 10 to the 5th on most calculators. You can do that on Desmos. And unless it's a really big number, Desmos sometimes when it's a very large power, it keeps it that way. But otherwise, it just moves it to the right. It's 135,000 is your decimal notation. Negative exponents, it doesn't matter whether that front number is negative or positive, really indicates that we are dividing by 5 tenths. Think about when I divide by 10 and divide by 10 and divide by 10, it's going to get smaller and smaller and smaller. That's why for this one, our decimal place needs to go back to its 0.0 thing. And we need 1, 2, 3, 4 zeros before the 3 so that that original decimal place can go 1, 2, 3, 4, 5 when it looks like that. So you just got to think negative exponents means I'm dividing by powers of 10. That number is getting smaller and smaller and smaller. if that helps you. But for some of these, you could just, put in negative 3.25, divide by 10, divide by 10, divide by 10, 5 times, and it will get it to you as well. Now, to multiply two scientific notation values, I think the easiest way to do it is to multiply the two numbers, pretend like you're just given 5.71 times 2.94. So if we just multiply those, you get 16.7874, okay? Now let's think about the tens. 10 to the 8th times 10 to the 3rd. If the bases are alike and you are multiplying, the rule is keep the base, add the exponents. So I would keep the base of 10 and write it as an exponent of 11. But here's the kicker on this, and here's the problem with this. If this front number is not a number between 1 and 10, we got to fix it. So we need to make this 1.67874 times 10 to the 1st. That's correct notation. But we have to add that 1 onto the 11 that was already there. So it's 1.67874 times 10 to the 12th. Now here's where I would suggest, see how this is 2 decimal places and this is 2 decimal places. This is a good one where using only those 2 decimal places might be a sound idea. But again, check how they want it entered. If we do the same amount of significant digits as we see up above, that would be 1.68 times 10 to the 12th. So yeah, that's how you do that one. Okay, 37. Here is a conversion one, or a dosing one. I'm going to show you the way that I set them up, okay? The medication should be a fraction on one side. So it's 8 milligrams per, put it as the fraction bar, 1 kilogram, okay? And then it says, what is the dose of a person weighing 32 kilograms? If I put 32 kilograms, it goes on the bottom because of the fact that I originally have kilograms on the bottom. My dose is milligrams, so this is my dose, and this is my weight. And so I have to be consistent on both sides of my fraction, so that's my unknown. That's where I put my x. And then we cross multiply. 8 times 32 is equal to 1 times x. Well, 8 times 32 is 256. That's milligrams. 1 times x is x. So it just tells us that we multiply by 8. Now, if you use logic that every kilogram gets 8 milligrams, 8 times 32, go for it. But they're not always that cut and dry, so I always like to use a proportion. It's very helpful. Just cross multiply to solve it. If a number is by your x or attached to your x, that's the number you're going to divide by. Here we're going from standard units into centimeters, but there's a problem. 8 inches is how many feet? Well, 1 foot is 12 inches. So how many feet would 8 inches be? Well, it ends up being 8 divided by 12. It's a fraction. It's not the whole thing. So 8 divided by 12 is 2/3. So it's 2/3 of a foot. Let me write that nicer. Sorry about that. So I know that 4 foot 8 inches is 4 2/3 of a foot. 4 foot plus some extra. And we want to know, well, how many centimeters is that? Now, on your conversion sheet, there's a little list that kind of goes between standard and metric and back and forth. And if you look at the length one, we know it gives it right there that 1 foot is 30.48 centimeters. So they have that conversion listed, so use it. Because 4 2/3 foot is how many centimeters? So our centimeters, I wrote it in such a way that my centimeters is in the bottom. So that tells me to put the X in the bottom. So feet on top, centimeters on the bottom. So then we're going to cross multiply. Well, in this case, we get X times 1. Well, that's X. 30.48 times 4 2/3. 30.48 times 4 2/3. You can do in Desmos. I can show you how. And I'll show you that in a second. But if you do it, your answer is 142.24 centimeters. Now, let me show you how you would do it in Desmos. If you enter in, let's see here. If you enter in 30.48, that's conversion, times, now here's the thing, it doesn't do mixed numbers very well, so this is what you have to do instead. You're going to put a parenthesis, and 4 2/3 is that very thing, 4 plus 2/3, 2 divided by 3. So that will take, and it will multiply 30.48 times the quantity of 4 2/3. And if you check our work, it is 142.24. It's the exact same thing that I got like on a standard handheld calculator. But you sometimes have to enter Desmos a little bit different. So my suggestion would be play with Desmos now. Make sure you know how to use it because it is your calculator that's available to you on the test. Okay, and it's free. It's just there's a free app you can get for your phone to practice on. There's also a web, a browser version. If you go to their website, it's just, and it is a very nice calculator, nothing wrong with it. You just have to practice using it. Okay. 75 centimeters to inches. There is a conversion on your conversion sheet that 1 inch is 2.54 centimeters. So how many inches would be 75 centimeters is the proportion you can use to set it up. So we're going to multiply that. 1 times 75 is 75. Usually one of them is multiplied by 1. 2.54 times x, I don't know what that is. It's 2.54 times x. But what that tells me is to get the correct answer, I have to always divide off anything that's touching my x. And so it tells me I do 75 divided by 2.54 to convert to inches. And so my inches are 29 point. Now it's 2 decimal places. So I'm going to go out 2 decimal places, 29.53 centimeters. Because it's a very long, it doesn't go in correctly. Okay, so that's that one. And that's it. So that's the last question for that. So I'm going to stop the recording. So thank you for watching that.